What if I told you that everything you've come to believe about the way of life and culture of indigenous peoples is a complete and utter lie? Forget everything you were taught in school. Are you ready to cast aside the veil of stereotypes and discover the shocking truth about ancient technologies that weren't just ahead of their time, but would leave modern engineers gasping in amazement? For decades, we were led to believe that the use of exclusively natural materials was a sure sign of a backward, utterly primitive society. We were presented with an image of savages wielding primitive sticks and stones. However, the latest detailed study of artifacts found from the mighty Iroquois tribe completely shatters this outdated notion. It turns out that behind the apparent natural simplicity lay ingenious mathematical calculations and a profound understanding of the laws of physics. Do you think that true, innovative high-tech only emerged in the age of factories and machine tools? Not at all. Be sure to watch this video all the way to the very last second, and you'll discover the incredible secret of the Native American craftsman. We'll show you in detail how, using technologies now long forgotten, the most ordinary bone was transformed into an incredibly complex, perfectly balanced engineering tool. It was a true ancient multi-tool that never broke, withstood enormous loads, and served its owner faithfully for over 20 years in the wild, unforgiving conditions of nature. What's more, I'll reveal one astonishing detail about this artifact that still baffles modern scientists to this day. What I'm about to show you is banned in 12 countries because it debunks common historical myths. We're used to thinking that true science began only in European laboratories, but the architecture of the material the Iroquois worked with required a deep understanding of mechanics. The material consisted of hard mineral crystals and flexible protein fibers. The right combination of these two elements yielded remarkable results in terms of strength. The craftsmen used thin stone blades to create deep guide grooves. These grooves allowed them to precisely separate the desired fragment without the risk of transverse splitting. The process resembled modern laser cutting, except that a sharp flint served as the tool. The groove was deepened until the internal stress reached a critical point. Then, a single light, precisely calculated blow split the workpiece exactly along the intended line. This method ensured the preservation of the material's most valuable structural fibers. No accidental chips or microcracks were permitted at this stage of the work. The perfectly smooth edge served as the foundation for shaping the future blade or cutting edge. The excess parts were sent for recycling to create smaller household items. Zero-waste production was another important principle of the Eastern Forest engineers. Gradually, the tool began to take on its final shape. Rough edges disappeared, and the surface became smoother and more aerodynamic. Every movement of the abrasive had been honed through hundreds of hours of practice. The master literally sculpted the shape, cutting away everything superfluous with mathematical precision. The result always matched the three-dimensional blueprint he had already envisioned in his mind. At this stage, all hidden defects in the material were revealed. If a void or crack was found inside, the workpiece was immediately rejected. The tool was meant to serve for many years in the harshest climatic conditions. Any hidden weakness could lead to failure at a critical moment. Therefore, quality control was incredibly strict at every intermediate stage. The blanks that passed inspection underwent finer grinding. Fine-grained stones and river sand mixed with clean water were used for this process. The surface was polished to a perfectly smooth finish that repelled moisture. The smooth surface also reduced friction during use, conserving the user's energy. This was yet another clear example of a deep understanding of ergonomics in physics. The tool's geometry was carefully checked for alignment. The craftsman assessed the symmetry and smoothness of the lines from various visual angles. The tool had to distribute the load perfectly along its entire length. Any asymmetry would lead to warping and rapid breakage under strong impacts. Only after achieving perfect balance did the intricate handwork continue. Upon completing this stage, the Native American craftsman had a tool with a perfect shape but insufficient hardness. Could you create such a precise part using only stone and sand? In the next chapter, you'll learn how heat treatment permanently altered the physical properties of this artifact. Watch the video until the end to find out the answer to this intriguing question. The hidden truth that everyone keeps quiet about lies in these people's incredible knowledge of chemistry. The Iroquois knew how to artificially increase the density of a material using complex thermal procedures. The workpiece wasn't simply heated. It underwent a multi-stage boiling process in special solutions. This process removed residual soft tissue and natural fats from the microscopic pores. Mineral substances then penetrated these pores, making the structure completely monolithic. Sturdy clay vessels, or wooden logs filled with hot stones, were used for the boiling process. The water was heated to a specific temperature, just short of a rolling boil. Wood ash and special plant extracts were always added to the water. The ash created an alkaline environment that gently cleansed the material's internal cavities. The extracts protected the fibers from degradation under the intense effects of high temperatures. The boiling time was strictly controlled depending on the size of the piece. Leaving it in hot water for too long made the material brittle, like thin glass. Insufficient boiling time left the internal pores clogged and prone to rapid decay. Artisans determined when the material was ready by a slight change in color and a dull sound when tapped. This sound was the main indicator of the correct internal structural transformation. After being removed from the solution, the instrument was immediately subjected to a rapid cooling process. It was immersed in cold running water, which caused the outer fibers to contract sharply. This contraction created enormous surface tension, similar to the professional hardening of modern steel. The outer layer became incredibly hard, reliably protecting the more elastic core. It was precisely this balance that ensured immunity to all known impact loads. The heat treatment process could be repeated 3 or 4 times to achieve the perfect result. With each cycle, the material became denser and heavier. Its structure increasingly resembled stone, yet it retained the necessary flexibility of living wood. Such a combination of properties cannot be achieved in any modern foundry. It was true engineering of natural elements, a skill mastered only by experienced craftsmen. At this stage, the tool took on a rich, dark hue. The color ranged from deep brown to nearly black, depending on the plant-based additives used. The smooth surface began to gleam slightly even without additional abrasive polishing. This color was not merely an aesthetic detail, but a sign of complete structural readiness. An experienced eye could immediately determine the quality of the product by the depth of its base tone. The product became incredibly resistant to fluctuations in temperature and ambient humidity. The tool did not crack in bitter cold or warp in the summer heat. This climatic versatility was critically important for peoples living in harsh winter conditions. The tool had to function flawlessly on any of the 365 days of the year. It was heat treatment that laid the unbreakable foundation for this incredible operational reliability. Artisans devoted enormous effort to every unit of reliable equipment they produced. They understood that the well-being of the entire large settlement depended on the quality of their work. Durable tools made it possible to build houses, create clothing, and prepare food efficiently. Therefore, every stage of the long production chain was carried out with the utmost physical dedication. The process tolerated no haste and demanded complete immersion in the routine. The result was a material whose basic characteristics surpassed even those of some metals of the time. What began as a natural raw material gradually transformed into a triumph of engineering ingenuity. Such technologies convincingly demonstrate the exceptionally high level of development of the Eastern Woodlands Native American civilizations. If you enjoyed this in-depth exploration of ancient technologies, be sure to like this video. The secret, passed down from generation to generation, lies in the unique angles of these blades. Sharpening such tools was radically different from sharpening iron or steel knives. The material required a special, asymmetrical profiling of the cutting edge to maintain maximum strength. An edge that was too thin would inevitably chip at the slightest contact with hard surfaces. An edge that was too thick would be unable to perform delicate cutting tasks effectively. The Iroquois used the principle of multi-stage beveling, which is applied today in the modern aerospace industry. The base sharpening angle was exactly 45 degrees to ensure maximum rigidity of the blade's base. Then a second, sharper angle was formed directly at the very edge. This created a sort of stiffening rib that reliably protected the working part from accidental breakage. Pressure was distributed evenly across the entire wedge-shaped working surface. The precision of the movements was strictly monitored by ear, based on the sound of the material rubbing against the stone. A change in pitch immediately indicated that the desired angle of inclination had been compromised. The master would immediately adjust the position of his hands, quickly restoring the ideal geometric shape. Experienced craftsmen could sharpen the tool even with their eyes closed, relying on muscle memory. This memory was developed over 10 years of continuous work in their native village. The tool's blade was often shaped like a pyramid, tapering smoothly to a single sharp point. 3 or 4 flat facets met at the very tip, forming an incredibly strong piercing element. This shape easily penetrated dense materials, gently spreading the fibers rather than tearing them. It never got stuck in wood or thick leather, even under strong physical pressure. This made the tool ideal for creating holes during complex sewing or large-scale construction. Periodically, the cutting edge was carefully polished with a piece of thick leather rubbed with fine river silt. The silt acted like an expensive polishing paste, removing the tiniest microscopic burrs. The edge became perfectly smooth, like glass, which significantly improved its cutting performance. A smooth edge dulled less during everyday use and could be quickly sharpened. This sharpening could be done literally on the go, without the need to search for a whetstone. The sharpening geometry always varied depending on the intended use of a specific tool. For sturdy scrapers, a single-sided edge was created, functioning on the principle of a classic chisel. For a fine awl, the primary emphasis was placed on the penetrating ability of a long, sharp point. For multifunctional knives, a compromise was chosen with a convex, lens-shaped blade edge. Each tool had its own unique formula for creating the ideal cutting edge. It is important to understand that each master had his own unique and inimitable style of geometric sharpening. The creator of an item could always be easily identified by the angle of the bevel and the direction of the micro-scratches. This knowledge was carefully passed down to apprentices as a vital part of the tribe's priceless heritage. The art of sharpening was rightly considered one of the most honorable arts in this society. It required impeccable visual judgment, a steady hand, and immense patience. Once perfected, the tool was fully ready for the final decorative finishing. The geometry of the edge was now ideal, but the working surface still needed to be made absolutely airtight. In the next chapter, you'll learn how ancient engineers achieved a mirror-like shine on their tools. How difficult do you think this process was without the use of modern industrial machinery? Final grinding and thorough polishing were the most labor-intensive stages in the creation of a durable tool. The surface had to be absolutely smooth so as not to trap any dirt or moisture. To achieve this, the craftsmen of the eastern forests used a whole system of natural abrasives they had found. The process began with small pieces of pumice, or porous volcanic rock. These stones gently removed the thinnest top layer, smoothing out any irregularities visible to the eye. The craftsman's movements were always slow, rhythmic, and strictly directed along the grain of the wood. Transverse friction could easily leave visible scratches, which would significantly weaken the structure. Gradually, the porous stone was replaced by increasingly smoother and harder rock types. Fragments of durable shale and dense quartzite found in the beds of local rivers were used. Water was constantly used to wash away the microscopic dust that formed on the surface of the workpiece. The polishing process always served not only an aesthetic purpose, but also a purely practical engineering function. A perfectly smooth surface significantly reduced the overall coefficient of friction during intense physical labor. The tool penetrated the material being worked on much more easily, whether it was hard wood or bark. This allowed the craftsman to exert much less physical effort and effectively conserve energy. Furthermore, spores of destructive fungi could not take hold at all on a perfectly smooth surface. A final mirror-like shine was achieved using small tufts of stiff, dry grass. Silica, found in large quantities in plant stems, acted as a fine polishing powder. The tool was rubbed with a tuft of grass until it began to reflect light brightly. The surface became incredibly hard and smooth, as if coated with modern glossy varnish. This stunning smoothness was absolute, without a single visible flaw or rough spot. It is noteworthy that even those parts that would later be permanently hidden beneath the handle were polished. The craftsman sincerely believed that the finished tool had to be absolutely perfect in every detail. An unpolished area could easily become a hotspot for moisture accumulation and subsequent rapid decay. Therefore, hidden areas were polished with the same incredible meticulousness as the working blade. This clearly demonstrates the incredible technical perfectionism of the ancient Native American engineers. The quality of the polish was regularly checked by slowly running the fingers over the surface of the work in progress. If the fingertips detected even the slightest physical resistance, the lengthy polishing process continued. The sensitivity of an experienced craftsman's hands successfully replaced modern electronic quality control devices. The tool had to feel in the hand like a completely natural extension of the living human body. Only then was it officially deemed fully ready for the final chemical impregnation. The smooth surface also made it surprisingly easy to clean the tool immediately after use. Any dirt did not penetrate the pores of the material, and could be easily washed off with plain clean water. This was extremely important for maintaining constant hygiene in conditions of close communal living. The instrument always remained crystal clear and fully ready for immediate practical use. The product's durability depended directly on the quality of this final mechanical finishing. The finished polish vividly highlighted the natural beauty and unique texture of this complex natural material. The gleaming surface revealed the unique, intricate patterns of the inner layers and structural fibers. Each finished tool became not merely an instrument of labor, but a true work of art. These important items were carefully preserved and often passed down as the most valuable heirlooms. However, to achieve the status of a timeless tool, one more crucial technological step was required. I discovered this quite by accident, while studying archaeologists' reports on the chemical composition of the artifacts in detail. The secret to the incredible durability of these tools lies in their deep impregnation with special natural oils. The Iroquois created very complex mixtures from various vegetable fats and coniferous resins. These components were always blended in precise proportions known only to the most experienced craftsmen. The resulting thick mixture created a completely impermeable barrier against destructive moisture and bacteria. The base ingredient was often oil pressed from ripe hickory or walnut nuts. It had extremely high penetrating power and did not go rancid over time. Pure pine or spruce resin, harvested at a strictly defined time of year, was always added to the oil. The resin provided the necessary structural viscosity and acted effectively as a durable natural polymer. The mixture was slowly heated over low heat until a completely homogeneous liquid mass formed. After being removed from the hot bath, the item was wiped down incredibly thoroughly with a piece of soft suede. All excess oil was completely removed so that the surface would not be sticky or too slippery. The instrument was then very gently heated over smoldering coals to polymerize the resin. The resin permanently solidified inside the pores, hermetically sealing them off from any external environmental influences. This created a surprisingly durable protective layer, integrated into the very structure of the material. To significantly enhance the effect, the impregnation procedure could be repeated 2 or 3 times over the course of a month. With each new application, the layer of polymerized resin became thicker and significantly more reliable. The surface quickly acquired a deep amber luster and a very distinctive coniferous aroma. This persistent scent reliably repelled insects and prevented the appearance of destructive pests in storage areas. The tool became completely impervious to the harsh and humid forest environment. Thanks to this powerful protection, the tool could remain in water for hours without the slightest physical damage. It did not swell, deform, or lose any of its phenomenal initial strength. This was critically important during long periods of work in marshy terrain or during prolonged rains. The craftsman could be absolutely certain that his tool would not fail him at the most crucial and difficult moment. The tool's impeccable reliability meant guaranteed survival in the harsh conditions of the eastern forests. The impregnation also reliably protected the finished tool from drying out in very hot summer weather. The natural oil retained the necessary minimum of internal moisture, preventing the material from becoming brittle. The ideal balance of elasticity and hardness was flawlessly maintained throughout its long service life. The tool seemed to take on a life of its own, successfully adapting to seasonal climate changes. This technology convincingly demonstrates the Native Americans' exceptional practical knowledge of material science. Thus, what was originally a simple blank was transformed into a timeless tool, completely impervious to the passage of time. It was fully prepared for the most grueling physical challenges of daily forest work. But how exactly was this tool securely attached to the handle so that it could withstand enormous impact loads? In the next chapter, you'll learn about the truly ingenious methods of secure fastening devised by Native American engineers. Creating a flawlessly perfect blade, or a sharp point, was only half of the craftsman's engineering challenge. An equally important and complex step was designing an incredibly reliable and ergonomic handle for the tool. A high-quality handle had to provide a perfect physical grip and dampen strong vibrations during powerful strikes. The Iroquois always used the hardest types of wood for this purpose, such as ash or old oak. The shape of the handle was carefully carved to fully account for the anatomical structure of the human hand. The point where the working part and the wooden base joined required exceptional structural strength. Tendons were often used for fastening, as they possessed incredible natural tensile strength. These tendons were first soaked in water for a long time, after which they became very soft and surprisingly elastic. They were wrapped incredibly tightly around the joint, with the coils carefully laid as close together as possible. As they dried, the tendons contracted significantly, binding the parts of the sturdy structure tightly and permanently together. For heavy tools constantly subjected to severe impact loads, a reliable mortise and tenon joint was often used. A deep groove was carefully carved into the wooden handle, precisely matching the shape of the shank of the heavy working part. The shank was inserted incredibly tightly into the groove, after which the entire assembly was securely fastened with sturdy wooden dowels. The dowels passed all the way through the handle and through special through holes in the tool itself. This tried-and-true method permanently eliminated even the slightest play between parts. Even after many years of intensive use, the entire surface of the wooden handle was carefully polished and deeply impregnated with the same oils used on the blade itself. This guaranteed to prevent the wood from cracking and reliably protected it from rotting in the damp forest environment. Sometimes the handle was additionally wrapped very tightly with thin strips of rawhide for the best possible grip. The leather quickly absorbed sweat from the palms, completely preventing the heavy tool from slipping out of the hands while working. The ancient craftsmen thought through the engineering ergonomics, down to the very smallest and most subtle details. The length and overall balance of the handle were always calculated strictly on a case-by-case basis for each individual type of tool. For axes and heavy work hammers, long handles were made to provide very powerful leverage. For small knives and fine awls, the handles were short, allowing for precise control of every movement of the blade. The tool's balance always had to be precisely at the point of grip, so as not to strain the craftsman's wrist at all. The ideal weight balance transformed heavy, routine work into a surprisingly easy and completely natural process. In the rich culture of the Haudenosaunee, the handle was very often adorned with incredibly intricate and beautiful geometric carvings. These carvings always served not only a decorative purpose, but also a very deep symbolic and social function. Complex patterns indicated membership in one of the clans, or recounted in detail the history of the tool's creation. The carving also significantly improved the grip by creating the necessary microtexture on the very smooth wooden surface. In this way, ancient art and stunning engineering harmoniously merged in every object created. If the handle was accidentally damaged in the field, it could always be replaced very quickly and easily. The unique design of the fastenings allowed the old wrapping to be carefully removed and the precious working part to be extracted without damage. A new handle was quickly carved from a suitable, sturdy branch and secured using spare tendons carried on the person. This incredible reparability was the most important engineering advantage of the modular design of Native American tools. Not a single truly valuable part of the tool was ever discarded needlessly. Various fastening systems were constantly refined, successfully adapting to new complex tasks and materials. Experienced craftsmen often experimented with different types of natural adhesives and methods for securing wooden parts. Knowledge of the most successful and reliable designs spread incredibly quickly among all the allied tribes. This constant exchange of technologies contributed to the tremendous collective progress of the entire vast Eastern Woods Confederacy. Engineering was an absolutely vibrant, constantly and dynamically evolving social process. The carefully fitted and comfortable handle made the tool truly technologically complete and ready for use. It represented a remarkably perfect balance between the power of the harsh natural world and the sharp human mind. Ergonomics thought out down to the smallest detail allowed one to work with this reliable tool from dawn to dusk without becoming overly fatigued. This was critically important during the challenging period of large-scale construction of longhouses or preparation for the harsh winter. The vast territory inhabited by the Iroquois, spanning the entire northeastern part of the continent, was characterized by an extremely harsh climate. Hot, humid summers were always abruptly followed by very cold winters with heavy snowfall and severe blizzards. Under such challenging conditions, absolutely any tool was subjected to immense physical tests of strength and durability. Ordinary wood would crack in the severe cold, and poorly treated materials would rot incredibly quickly due to dampness. Therefore, climatic resilience was the most important criterion for the quality of absolutely any item produced. Frequent shifts from high humidity to extreme dryness always posed a particular hidden danger to tools. When a finished product became thoroughly soaked and then dried out incredibly quickly by the hearth, severe internal stress would build up. In ordinary materials, this inevitably led to deep cracks and complete structural failure. However, the composite nature of properly processed natural raw materials surprisingly easily absorbed these dangerous stresses. The fibers would stretch only slightly and then return to their exact original state without the slightest damage. During hard labor in the cold open air during the winter, the blades never froze to the wood. The smooth, perfectly polished surface, deeply saturated with oil, instantly repelled water and ice crystals. Snow slid off the tool very easily, without forming a heavy crust of ice that would make physical labor more difficult. This always made it possible to chop firewood or quickly build temporary shelters even in the fiercest winter blizzard. The phenomenal reliability of the equipment was the key to successful survival in the frosty forest. During the difficult spring thaw, the main problem was always the constant, bone-chilling dampness and mud. The ground quickly turned into an incredibly sticky swamp, and the cold air was saturated with thick, damp fog. Any untreated wooden objects would become covered with destructive mold in literally just 2 or 3 days. But the powerful antiseptic properties of coniferous resins provided incredibly reliable protection for tools against any fungal infection. Dangerous bacteria were simply physically unable to multiply on such a polymer surface, which was highly hostile to them. In the summer, many tools were often exposed to intense direct sunlight during grueling fieldwork. Ultraviolet radiation rapidly degrades the vast majority of natural materials, making them very dull and extremely brittle. However, the dense mineralized layer provided incredibly reliable protection for the inner fibers against damaging solar radiation. Any tool could safely remain under the scorching sun all day long, without the slightest damage to its structure. The ingenious craftsmen even took this very subtle and non-obvious factor of climate-induced material degradation into account. Thus, all their equipment was 100% fully adapted to the complex ecosystem of the eastern forests. It represented a stunning technological response to the serious challenges posed by the continent's harsh and highly variable natural environment. This incredible adaptability always allowed the Iroquois to very successfully develop their complex society and build large settlements. They were completely unaffected by unexpected weather fluctuations, always having such reliable tools at their disposal. Climatic resilience also made the Confederacy's long-distance expeditions and complex diplomatic missions incredibly easier. Envoys and hunters could confidently take only the bare minimum of tools with them, absolutely certain of their 100% reliability. They no longer needed to carry heavy spare blades in case their primary equipment broke unexpectedly along the way. This significantly increased the overall mobility of the expeditions and their speed of movement across vast, unexplored territories. This stunning technological superiority provided the tribe with a colossal logistical and strategic advantage. The versatility of all these artifacts still amazes many modern engineers and renowned researchers. They incredibly successfully combined the strength of stone, the elasticity of wood, and absolute resistance to corrosion. Unlike the very first iron tools brought by the colonists, these tools did not rust at all and did not become dull when striking ice. They were the absolute embodiment of their environment, created solely for complete domination within it. The vast range of applications for these tools encompassed absolutely every aspect of the complex life in the Haudenosaunee settlements. They were always used to construct gigantic longhouses, reaching 10 meters or more in length. Massive, sturdy wedges were used to quickly split tree trunks into surprisingly smooth planks. Sharp, thin chisels made it possible to create highly intricate grooves for perfectly joining the wooden framework without a single nail. The engineering of all these structures relied entirely on the phenomenal reliability of these hand tools. No less important, and no less complex, was the role of these tools in the process of crafting means of rapid transportation. Lightweight and maneuverable canoes, made from elm or birch bark, required truly precision work with the materials. Thin, sharp awls were always used to pierce numerous holes in the bark before sewing the pieces together with fir roots. Very sharp knives allowed for the precise and rapid removal of excess material, creating the canoe's ideal hydrodynamic contours. Without high-quality tools, building such a reliable boat would have been absolutely impossible. Tools specifically designed for creating intricate works of art and ceremonial objects held a special place of honor. Carvers crafted the most complex ritual masks from wood, richly decorated with deep relief and exquisite intricate details. Such intricate work required chisels with vastly different sharpening angles and handles with perfect weight balance. Masters always valued their tools as highly as gold and trusted no one else with their delicate sharpening. The quality of the final carving depended directly on the incredible sharpness and correct shape of the blade used. In complex diplomatic relations, a high-quality tool often served as an incredibly valuable gift. Allied tribes were always presented with skillfully crafted knives as a sign of deep respect and the most peaceful intentions. These items symbolized a great willingness to share technology and to constantly maintain strong ties between peoples. The quality of a costly gift always reflected the high status of the giver, so only the very best examples were exported. Thus, a high-quality tool became a very important instrument in the art of subtle diplomacy. Training in the proper handling of this arsenal began at a very early age in absolutely every clan. Teenagers watched the elders work very closely, learning the correct grip and the ideal angle at which to apply force. It took them a very long time to learn to understand the complex properties of the materials and to care for their very first knives, which had been specially crafted for them. Proper handling ensured that the tool would not be broken due to the slightest clumsiness or childish carelessness. A strong work ethic successfully fostered an incredible respect for objects created by human hands. The crafting of entirely new tools never ceased. It was a constant background process in every settlement. On long winter evenings, when field work came to a complete halt, the craftsmen focused on renewing all their equipment. By the light of the central hearths, they spent long hours polishing new blades, weaving sturdy wrappings, and carving new handles. This highly rhythmic labor created an amazing atmosphere of calm and incredible confidence in the future. The entire tribe knew for certain that by the time spring arrived, they would have everything they needed. It is important to note that these tools were completely eco-friendly and fit harmoniously into the cycle of the harsh natural world. After many decades of service, when an item finally became unusable, it simply returned to the forest soil. Natural materials decomposed very slowly, leaving absolutely no toxic or hazardous waste behind. This fundamentally and completely distinguishes the sophisticated technologies of indigenous peoples from modern industrial toxic production. They simply took only what was absolutely necessary from nature and always returned the remains without harming the environment. Their phenomenal versatility, reliability, and ease of maintenance made these items the foundation of the Haudenosaunee technological way of life. They consistently enabled the people to develop a highly sophisticated culture, advanced agriculture, and a powerful forest confederation. Every tool was not merely a soulless object. It was the most faithful ally in the struggle for prosperity. And this reliable ally always served its owner faithfully for many decades. The main secret to the incredible longevity of these tools lies in the remarkable synergy between technology and meticulous care. 20 years of uninterrupted service is not a myth, but a historical fact officially confirmed by researchers. Over this long period, 3 or 4 generations of wooden handles have come and gone, but the working blade itself has remained completely unchanged. The secret has always been that the original engineering built an enormous reserve of incredible strength into the material. The internal microstructure was modified to successfully withstand the test of time and constant severe wear and tear. Regular and very thorough maintenance was treated as an absolute rule for every owner. The tool was never, under any circumstances, thrown into the mud or left out in the pouring rain unless absolutely necessary. After absolutely every use, it was wiped down incredibly thoroughly to remove any traces of tree resin or damp soil. The blade was always coated with a thin layer of protective animal fat before being put away for long-term storage. This simple routine took 2 minutes, but was guaranteed to add many years to the tool's overall service life. The incredible elasticity of the material, achieved through a complex process of heat treatment and oil impregnation, always played a huge role. Even under extremely critical loads, the tool never snapped in half like brittle glass or low-quality cast iron. It would merely spring slightly, effectively absorbing all the impact energy and thereby protecting its internal structure from destruction. This incredible micro-cushioning was the most important protective mechanism built in by the ancient craftsmen during the manufacturing process. It always successfully compensated for very minor user errors during heavy physical labor. The specific storage conditions in longhouses also contributed immensely to the excellent preservation of all work tools. Tools were always stored in special dry niches or hung on straps in well-ventilated areas under the roof. Smoke from the hearths provided constant, powerful fumigation, repelling all insects capable of damaging wooden parts or tendons. A stable temperature and very moderate humidity created a simply ideal microclimate for these complex composite materials. The large house reliably protected all the tools, just as they had always helped to build that house. A very strong emotional bond between the owner and his tools also played an important role in their preservation. Any object into which so much hard work and craftsmanship had been poured was always perceived as an animate helper. It was cherished deeply, a source of immense pride, and constantly adorned with personal symbols and clan insignia. It was absolutely impossible to treat such an important object with disregard or negligence. This complex psychology of respect for objects was the very best guarantee of their incredibly long and faithful service. Passing down any valuable tool was always accompanied by strict instructions on how to care for it properly. A very old master passed on not only the blade itself, but also all the accumulated experience of working with it over many years. The younger generation always received a time-tested object with absolutely perfect ergonomics. This incredible continuity ensured a seamless cycle of use for high-quality items throughout the entire community. High-quality items often outlived the people themselves, becoming a vital link between generations. When we compare these ancient technologies with the very first examples of colonial tools, we see a striking contrast. Imported iron axes and knives rusted incredibly quickly in the humid climate of the North American forests, literally within a single season. During extremely severe frosts, poor quality imported iron became brittle and broke from even the slightest impact. Traditional Native American tools, on the other hand, continued to function flawlessly under the exact same conditions 365 days a year. They far surpassed their imported counterparts in absolutely every aspect of durability and reliability. The history of these truly unique instruments is a story of profound understanding of nature and ingenious engineering. They have convincingly demonstrated that incredibly complex technologies can successfully coexist in harmony with the environment. Their creation has always required a deep knowledge of physics, complex chemistry, and biomechanics, knowledge accessible to the Haudenosaunee artisans. This great historical legacy deserves the most rigorous scientific study and respect from the modern technological world. We've taken a detailed look at the incredible engineering behind these ancient tools, which served their owners for decades. These technologies prove that the history of the indigenous peoples of North America is full of amazing discoveries and the highest level of craftsmanship. Please suggest topics in the comments for future videos that you'd like to see on our channel. And don't forget to subscribe so you don't miss out on new and exciting historical explorations.